Hello and welcome. In this discussion, we're going to talk a little bit about Model View Controller and as it applies to the overall application structure of an iOS application or an iPhone app. And as we discuss this, we're going to be talking at kind of a high level of detail. We're going to fill in a lot of concepts as we go through the course, but I wanted to expose you to some of these ideas so that we have a common ground to talk as we proceed with the course. So the overall application structure of an iOS 6 application is a design pattern that we refer to as Model View Controller. This is a three-part design pattern, and the model view and controller have to do with the classes that make up the overall architecture of the application. The model classes will encapsulate the data and operations on that data for the application, all of it. So really, the model is what the application is. The views, of course, are the user interface. This is what the user sees and will interact with. And the controller classes function as sort of the glue. They are the telecom switch, if you will, between the model and the view. So the controller classes will instantiate the model, and they will conduct all the communications between the model and the view. If the user selects a control, touches a button, or so forth, the controller will deal with that interaction and will make appropriate adjustments to the model if necessary. So in iOS, if we're talking about views and controllers first, a view will never exist without a controller. There is no way to make, let's say, well, there is, but a view really never exists without a controller. The primary controller class is named UI View Controller. Now, UI View Controller has several subclasses that we'll be talking about throughout the course. But a basic UI View Controller class is made to handle interactions with a view. Views are created in Interface Builder. Interface Builder is a sub-application of Xcode. Prior to, I think, Xcode version 4, Interface Builder was a separate application. But with Xcode 4, Interface Builder is now wrapped into the Xcode application. It is part of the application itself. So we build views in Interface Builder, and then we wire the controls up to the view controller. Each view is assigned a view controller through the file's owner attribute in Interface Builder. Now, there are other ways to build views, but they will still have a view controller. We don't have to build a view in Interface Builder. We can actually create a view on the fly as a UI view, but it will still be a view of a view controller. So remember this pair. Views never exist without view controllers to control them. So the UI view controller maintains two kinds of connections to its view. It maintains what are called outlet properties for controls that the controller has to change, and these are called passive controls, and action methods for controls that need a response to be done in the controller, and these are called active controls. An example of a passive control is a label whose text we change in response to some other event. An example of an action or an active control is, say, a button that we must write a function or a method, and that'll be a method of the view controller, to do some work. Model classes, we've talked about views and controllers. Model classes are created by us, and they're usually subclasses of NSObject or one of its near subclasses. The model itself as an entire entity, whether it's one class or several classes, this entity is always instantiated by some view controller. It's usually a UI view controller, maybe a subclass of UI view controller, but the model itself is always instantiated by a view controller. Some classes within the model, let's say, may be instantiated by the overall model itself. Of course, this is a class graph. We're familiar with that idea. But the model itself is instantiated by a view controller. In model view controller architecture, the model and the view never talk directly to one another. In other words, we would never put an outlet property or an action method in a model class object. We put the outlet properties and the action methods in the controller, and we never allow the model and the view to directly communicate. There are a couple of design patterns we use for models and controllers and views and controllers to communicate to make sure that the controller gets the message back and forth between the view and the model. And these two design patterns are called delegation and target action. And we'll talk in detail about these design patterns in upcoming units of the course. So the basic message here is the controller handles all communication between the model and the view. So in iOS applications, there is a single class called AppDelegate that responds to lifecycle events. Things like the application is becoming active, is being displayed, is going away, is being hidden. The application came up for the first time. These are what we call lifecycle events that the AppDelegate class responds to. So how does all this happen? Well, it's very simple. In the main function, a call is made to UI application main. This is a function, a C function, that returns an int. And then the main function just returns the integer that it gets back from UI application main. The real purpose of UI application main is to wrap up the run loop of the application. We pass in the AppDelegate as a string to UI application name. So when we say we pass in the AppDelegate name, we use this method in a string from class, passing it the AppDelegate class. And that is really what tells the run loop, the UI application, to use AppDelegate as the responder for all lifecycle events. So when main is run, the run loop begins because we've called UI application main, and the run loop uses AppDelegate to respond to these application lifecycle level events. So that's how that works. AppDelegate, when it fires the event that the application did finish launching, and that's what it's called, application did finish launching with options. That's what that event is called, that method is called, and we'll look at that in some of the demos that you have associated with this unit. That method, when it fires, will set up the controllers and set up the views and make sure everything is working for that first view of the application. So that's how all that fits together and works. Thank you very much.